Okay, let's look at an example. This is kind of like what we've been doing the past few days, just given a different name, some different notation. Remember, for part A here, the derivative of f of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. So that's basically our general derivative. If we were to do part B, let's say that's all we had to do, for that, the derivative of f of negative 2 would be f of negative 2 plus h minus f of negative 2 all over h. Of course, we're taking the limit of that as h approaches 0. So we'd have to work all of this out with negative 2 in there, but then part C asks us to do the same thing with 3, so we'd have to do all that work. We talked about this yesterday. If we have to find the same derivative at a few different points, it helps to just do it in general, like part A, and then all we have to do is plug in these values at the end, rather than doing all the work multiple times. So if you were just asked to do part B, this is how you could set it up. Since we're finding the derivative at two different values, negative 2 and 3, I'm going to do the general derivative in part A, plus it asks us to. But I'm going to do that first, and then we can just plug in negative 2 and 3 into our answer. So let's take a look. For part A, we've already set it up right here. Now, we have to take x plus h and substitute it into the function for x, just using function notation here. So we have limit as h approaches 0. X plus h goes in there, so we have 3 times x plus h squared minus 5 times x plus h plus 4. So that's our f of x plus h part. Right? That's this portion. Next, we have to go ahead and just do minus f of x. So we're putting x in here. Really, all we're doing is taking the original function. So we're subtracting f of x. We're subtracting this whole thing. So you need to remember to put parentheses around it. We're subtracting everything. Or if you don't want to put the parentheses, make sure you distribute that minus to each term right off the bat. All right, so f of x plus h is our green part right here. Minus f of x is just the yellow part. Now, like you've seen the past few days, we just have a bunch of algebra to do next. So x plus h squared, we're going to multiply that out. Remember, that's x plus h times x plus h. That would give us x squared plus 2xh plus h squared. Minus, distribute that 5, we get minus 5x minus 5h plus 4. And distribute our minus into this trinomial. Minus 3x squared minus 5x plus 4. All over h. One more thing to distribute. We can distribute this 3 in. We get 3x squared plus 6xh plus 3h squared minus 5x minus 5h plus 4 minus 3x squared minus 5x plus 4 all over h. So now we can look for those things to cancel out, and this is going to simplify. We have the 3x squared minus 3x squared. I forgot to distribute here, like I told you not to forget. We have the minus to each of these, so minus negative 5x, that's actually going to make it plus 5x. And then the minus 4 becomes minus 4. Hopefully some of you were just yelling at the screen while I was doing this, saying that I made a mistake, but I caught it. Alright, so we've got negative 5x, positive 5x cancel out, positive 4, negative 4 cancel out. And that's kind of what I told you the other day is if things don't cancel out here, you know you made a mistake somewhere. So I knew, okay, those 5x's should have canceled out. I knew to look back at what I did, and I didn't distribute that minus. Now we get something a little bit more manageable. The limit as h approaches 0 of 6xh plus 3h squared minus 5h all over h. So all we have left should have h in it at this point, which means we can factor an h out of the top. So we get h times 6x plus 3h minus 5 all over h. Once these h's cancel out, now we can use direct substitution. We can put 0 in there. If we put 0 in for h, this x is still there, so 6x, this becomes 0 minus 5. So really, our derivative comes out to be 6x minus 5. For our problems before, we were not getting an expression, we were just getting a number. That's when we plug a number in right off the bat. If we're doing it in general, we should get an expression here. And that expression is what we're going to use for part B and part C. Makes it easier. Part B, if we want to find the derivative of derivative f at -2, we're just putting -2 into this function. Right? We have a new function here, derivative f of x. So 6 times -2 minus 5, we get -17. And same with C. We don't have to go through all this work. May have been easier with numbers in there, but we don't want to have to do it twice, one for each of these. So now we find the derivative of f of 3 just by putting 3 into our function. 6 times 3 minus 5, we get 13.